Alright, welcome everybody. This is Alec here at Kaufman Space Works. So, this channel was supposed to start out as a reflection on my L1 attempt, hopefully being successful. It did not go very well. That's besides the point. Today we're going to be moving into my L1 second attempt, what we learned from the first one, and how we're designing the second one to avoid what happened on the first one. So let's get right into it here. So starting things off, our L1 attempt, our first attempt airframe was a 3-inch diameter. It was running on a 29mm motor. Now, it's an H115. I didn't write that in here. It was an Aerotech H115 DM. I ran it on the standard 14 second delay, and you'll see why I did that here shortly. Had through the wall fins, also had strakes. We were running a baffle system as well as a parachute protector. We were running a Nomex blanket around our parachute. Had an apogee around 1900 feet, and it had a 36-inch parachute. Now, the results. We had a very nominal launch. Parachute deployment went very well. Now, the high level winds on this day were pretty high. We were looking at about 20 miles per hour. Plus, ground winds weren't too bad. We were at about 10 miles per hour. And this thing, as you can see, sailed off into the sunset, was not recovered. The launch, I will say I don't have a great recording of it, but I will put it in here in a moment. The launch went okay. We had a really good launch off the pad. It was beautiful. It reached apogee. The winds were so high, it just kind of sat there. It just coasted in the air. And inevitably, I kept this 14-second delay because I knew the winds were high, but not as high as I anticipated. And, well, it was kind of just floating up there. The 14-second delay did kind of what I wanted it to do. The plan was for it to fall about a couple hundred feet before it deployed the parachute to at least try to get under some of the wind. That didn't go as planned. It kind of just sat up in the wind and deployed the chute. And it coasted, it undershoot for a long time. It ended up across the street from the launch site in the woods. I went looking for it immediately. Had with the best bearing I had at the time. I searched for about an hour, didn't find it. Packed up my stuff so I could go search some more, and I got a new bearing from someone who was closer to where it went down. And I searched for about another hour. Heading in that direction, fanning out as I got further. Still didn't locate it. I was checking up in the trees and everything. It had a 36-inch parachute. It was white and orange. I should have been able to find it. I'm thinking it went a lot further than I expected. I should sim it out and maybe see if it went further. I will say the neighbors of this launch do tend to find rockets occasionally, and they do return them. So maybe we'll get it back, but it won't help me in any way. So just popping in here, guys. This is going to be the launch right here, and let's get into it. So right here, guys, you see we had a really stable launch. Everything looked good, and here in a moment, it's going to go out of frame, and I didn't record this. My brother was recording so I could watch my flight more, and you'll see it deploy slightly after he loses frame, and then it'll pick back up here.
Yep, I still got it. It's a long delay. Woo! Shoots out.
I'm just gonna pop in here, guys. So we see the chute's deployed here, and as we can tell, it is very high up right now, and that wind is just taking it. It is blowing way up there, and it's just carrying it. And at moments, this thing felt like it was being just lifted by the wind, not just being carried, just straight up lifted. So this is we're just following it here for a minute, and here in a moment we'll see it go down below the trees, and we'll swap over and we'll take a look at how the recovery went looking at a map here. But
I think you're
just
going to be over the street.
thinking about 20-30 seconds, you'll see
you're
it
over
start
Webster
to
Road.
fall below the tree line. And from our
It is.
perspective,
Wow.
it is not where it actually ended up. So,
Do you have any kind of location?
so here we go. We're getting
on it?
close to the tree line here. And of course, right here, we'll see it fall in
Quite a bit
between
farther
these
than I
two
thought.
taller trees you can see here. And they'll zoom in here momentarily, I think.
Well, I better start walking.
Yeah, try to
And you
get
just
an
hear me
angle on
there.
it
I
when
better
it comes
start
down.
because it's about a solid half-mile away minimum.
I don't know, how do you
And
track that,
it's
Brad?
below the trees there. So now let's move on to the recovery analysis. Alright guys, so popping over here to Google Maps, let's take a look here. So the launch site, it's out on this airport. It's an ultralight airport. So the video is taken from right around here. And the launch pad itself is sitting right here, right around here. Kind of in this area that's not technically runway. So the launch pad's right here. And when we see it go below the trees we're looking at right around here. Now, from our perspective, it looks like it went down somewhere back here behind these houses, down over here. But I later find out there's the registration guy, the guy who sits up in our office here. He was outside during the launch, and he says he watched it fall right here. That's where he lost behind the trees. It was right directly behind this house. So, following that, I got permission from the homeowner, and I started walking out this way. I kind of fanned out from this area, so I got a pretty decent fan going here. The brush it's not as thick as it looks here. I could see all the way down here up in these trees and stuff. So I'm looking here. When I got out to this kind of clearing area, I walked all the way down here and all the way up here, close to this guy's yard. Just kind of passed back through here. I didn't see anything. And then it really lightened up in here, so I just went all the way back to this field, just like this whole cone here. So working back from this house, I kind of searched this whole area here. And the way the wind was blowing, I knew it probably wasn't south. It was definitely on the northern side here, and I worked all the way back to this farm field. There's no crops in it, so if it landed here, I would have seen it. And so going this far back, I mean, launch here, land here. There should be a way to measure here. Measure distance. All right. So from about here to even just where we saw it. I mean, we're approaching half a mile here. And if it kept going, I mean, that gives us a pretty decent bearing. So across street, this house, we saw it go below the trees. It was probably sitting back around here when it went through the trees. So knowing that, if it kept going, it probably would have landed like right here. If I didn't see it anywhere in here. So, could be just in someone's backyard and I couldn't see it and all kinds of things, but safe to say this thing went pretty far. So, let's jump back to the analysis here. Moving on, our lessons learned. We're going to make the next one fat and heavy. Alright, we want to keep it low. I know the notion is low and slow, but I kind of threw that out the door, and I just wanted a cool rocket. Try and keep this apogee as low as possible, and if needed, we're either going to use a shoot release or dual deployment. So let's get into our next rocket here. So our design requirements, we're running a 4-inch diameter. We're going to do through the wall fins again. We're going to do a 29mm motor. I'm hoping to launch it on the same motor, an H115DM. We're going to shoot for single deployment. That is the goal, and keep an apogee under 100 feet. So let's move over to the rocket file. Alright, so this is what I have started so far, guys. Um, we're looking at a overall length of 135 centimeters. We might boost it up a little bit, just get some more mass in her. Um, our stability is good. We got 1.33 cal. That's right where we kind of want it. Between 1 and 2, closer to 1 tends to be a little better. We're not going too fast. Max velocity of 258 feet per second. And our apogee, this is the key here, 997 feet. We're under that 1,000 feet. If needed, I will probably add some ballast in this thing, and we'll get some more accurate weights as we get there. The last rocket had technically 8 fins if you include the strikes. This one we're going 3 fins. I'm gonna do these out of basswood. I'm just gonna cut them out, and I'll be using my 3D printer to get a cutting jig put on here. We'll cut these out, put them in once this first motor tube is in, hopefully. We'll cut first and then do the motor tube so I can align it better. But we'll do this motor mount tube. We'll do the first 2 centering rings. I still have to put rail buttons in here, but we're just going to use some 1010 rail buttons. We're going to run, this was the closest shot cord I had here in open rocket. We're going to probably run some 750-pound Kevlar. Totally overkill, but I don't care. This is I think this is an OGIV, yep. We're using a PNC 3.9. I'm pretty sure it's a lock precision. Yeah, it's a lock precision nose cone. Most of the parts are coming from lock. We're just using some thick walled tubing, that kind of thing. I think it'll turn out pretty well. I'm hoping to launch here in July. It's a ways out. This rocket actually won't take me very long to build, and we'll do some videos on the building. But I am pretty filled up during the launch time, that is in June, because I just launched over this past weekend of recording this. And we're going to move on to looking at July. In June, I'll be launching. I am a college student, and I do compete on a rocketry team, so I'll be launching down in Texas at the International Rocket Engineering Competition. And so somehow I'm trusted with an entire avionics and recovery system, but I can't even land my own L1. But that's where we're at right now. And then we'll move on here and look at some of the future projects that I kind of have in mind. All right, so moving on into some future projects here. This isn't totally perfect quite yet, but at the moment we're looking at this rocket here. It's called Cerberus Mark II. Cerberus Mark I actually flew about a year ago. It was my first attempt at building my own home-built avionics bay with my own flight computer. It was running on a Pi Pico 2, and it went pretty well. The launch, I did not recover. There was a failure in the motor ejection. The powder didn't fully ignite. There wasn't enough pressure on the ejection charge, and it didn't deploy the chute. Other than that, because it was all built-in ejection charge, so there's nothing I could really do there. But besides that, it actually went pretty well. Launch was good. The launch right angle, everything was beautiful. It was just a failure to deploy chute. It hit the ground ballistically, and it was craft paper, pretty thin craft paper, and if anything survived, it would have been the fin can, but I even doubt that. It was ASA, and I did the math, came down with about 8,000 joules of energy. That thing wasn't surviving. It is now one with Mother Earth. But now we've got Cerberus Mark II. This avionics bay right here is probably going to get shortened. This tube right here, we're probably going to shorten this down. I got to look at what kind of hardware I'm going to be using fully. The flight computer that was going to go into this is actually getting fully redesigned. Gives me more time as well, because I failed my L1, to look back at my designs and probably improve on them. Now, currently you'll see this thing has strikes. I like to 3D print my fin cans, and so moving forward, I had a design we'll pull up the CAD here in a minute and I'll show you. But the strake mounting is being changed because this, I'll explain further on this, the design of this rocket, but it will be modular in a way. We're looking at the booster to be primarily interchangeable. It's planned for 38 millimeter motors with reloadable motors instead of single use, save some money. And um, also this upper section, the avionics bay is going to be the main piece here. It's not going to change too much. The primary changes are going to be computer changes, any kind of like internal hardware changes, but the plan is to keep this the same. This is flying as well a 4-inch diameter. It's running on thick wall tubing, the same tubing I'm going to be building the next rocket out of, my L1 attempt 2. And let's move over to the CAD and I'll explain some more. So here's the CAD model of Cerberus Mark II Block 1. At the moment, there have been some changes. The modeling is still getting up to date at this time, but I'll show you what's changed, what's staying, so on and so forth. So let's do a little chop in half here. So we got the fin can down here. You'll notice there are these big poles here. These were used for mounting the strakes originally. Those are actually going to go. And since then, we've also rotated the strakes 45 degrees off center with the original fins there at the bottom. And so I still have to move those and so on and so forth. Oh, this is the one thing I don't like about Fusion, but we'll get past that. All right. So that's changing. The way it's changing is here. Let's go from this angle here. So as you can see, these new bars that are up here, they'll be able to house this bottom hole for the mounting screw. And we'll be using heat set inserts for that. And then up here, we're going to have a separate kind of like top cylinder, similar to the setup of this here. It's going to be fully hollow in the center so we can pass a shock cord through it. But that'll house the upper mounting holes for the strakes as well. Now, to connect the two other than the strakes, because I don't want the strakes being the only connection between these, I'm going to put some kind of in place of these bars here. There's going to be some small carbon tubes that are going to run from here to there. This way we get a more solid inner structure that hopefully, because everything's being screwed in on this fin can, I can remove the outer screws and just slide out this entire internals. Now, when we're talking about the modularity of this thing, you'll realize that this isn't the like largest size we could go motor wise. Actually, most motors will extend out the top of this. So there's some plans in the works to kind of have almost stackable sections down here for larger motors, just to add the stability there. And you can't really tell, but this is a little wide for a 38 millimeter motor. We actually have some insulation sleeves that are made out of nylon carbon fiber that slide in here, and the motor slides into that. And then there's a motor retainer that mounts to the outside and screws up through the bottom of the fin can. And you'll see here as well that the bottom of the rocket, the body tube, rests on this surface here. So the force of thrust goes through the fin can. You'll get some transmittance through the screws for the strakes, but that's not our primary mode. It's mostly this bottom surface here. We're going to be pressing up against on this surface here off of the sleeve, and then that force is transferred up through the body tube. And there will be screws on the outside holding this in. I just haven't modeled them yet. Moving up here, we're getting towards the section that is our avionics bay. So this section here is generally going to be our untouched section. It'll change with flights, obviously, because we're going to be moving into active control on this lower section, and we can design different levels of payload. The idea, though, is that we can have maybe a couple different boosters. One's on an H motor, one's on an I motor, whatever. We could always swap the booster and we could fly it. Then I'd love to get into up here is our one of the parachute bays. Maybe in our nose cone, because our nose cone will be printed, we can look into some custom stuff in terms of cameras and things of that sort. Maybe a scientific payload up in the nose cone. We can do all sorts of stuff. But this kind of gives us a platform to work with. Block 1 is meant to mostly be a testing platform. Test if the designs of the booster are going to work well, if they can hold up, if my computer is working well, mostly to get our first set of data for the new computer and see how it's reading out, that kind of thing. Do all sorts of testing on this platform. And then as we move forward, block 2, block 3, block 4, we'll just see systematic improvement there and just slowly break it down. And as an engineering student and someone who does collegiate rocketry, we will be breaking this down as we really get into it past our L1 cert here of we'll be doing some systems engineering and kind of breaking down that whole process, especially when we get deeper into the Cerberus platform here. Just want to thank everybody for stopping by today and listening to my spiel and our plans moving forward. And hopefully I can see you guys in the next one.